So we'll start with B-spline curve properties. Now you have heard what is B-spline curve, right? Let's revise in short. What is interpolation? Interpolation is a technique to generate smooth curve, and it must pass through all the sample points. Here the blending sum of the blending functions must be 1. Then what is B-spline? B-spline curve. B-spline curve is used to, or we can say it is used to smoothen the curves and corners, right? In this case, what we have done, all the sample points which are given in interpolation, it is compulsory that the curve should pass through all sample points, but in B-spline it is not compulsory. We just drag the curve in such a way that it gives a proper shape. Even it's not compulsory that it should pass through all the sample points. Now we'll see the properties of B-spline curve. So these are the properties which can be seen. B-spline curves is important. B-spline curve, interpolation are important from exam point of view, and actually they are very simple. The basic diagrams and the theory is all simple. Once you get the concept, you can write it by yourself. So these are the properties. You should know the properties. If you have understood B-spline curve, the properties are very easy to understand. So now the first is the sum of B-spline basic function for every parametric value of u is 1. Obviously we know that the basic function, that is the parametric value of u, is always, it has to be 1, like also in case of interpolation the blending function has to be 1. When it's 1, it gives a smoother curve. So here we can say that I equals to 1 till n plus 1, where n of I and k of u equals to 1. That is, here u value of u will keep on, it won't change, and its parametric value should be 1. Now each basic function is positive or 0 for all parameter values, right? Each basic function is positive or 0 for all parameter values. It can't go in negative in case of B-spline curve, right? So therefore we can say n of I comma k should always be greater than or equal to 0. Now except for k equals to 1, each basic function has precisely one maximum value. Except for k equals to 1, whenever it's k equals to 1, it can't have a maximum value, as for k equals to 1 it gives almost an accurate and smooth curve. Then the maximum order of the curve is equal to the number of vertices of defining polygon. Yeah, this is the obvious point. Then maximum number, also the maximum order of the curve is equal to number of vertices of the defining polygon, because maximum times it is considered that it should go through the, it should pass through the sample points, or approximately it should pass from near the sample points. Next, the degree of B-spline polynomial is independent of the number of vertices of defining polygon, right? Because it is so, because when we stretch the polygon, or when we stretch the curve and shape, it is not compulsory it should pass through the sample points. So it doesn't matter, or it is not dependent on the number of vertices in this case. Now the B-spline allows local control over the curved surface, because each vertex affects the shape of curve only over a range of parametric value where it is associated basic function is non-zero, right? When the basic function is 0, the shape is accurate, but if it's not 0, in that case it will affect the shape. The curve exhibits the variation diminishing property. Thus the curve does not oscillates about any straight line more often than its defining polygon. The curve exhibits the variation diminishing property. Thus the curve does not oscillates, right? In case of polygon, it's made of straight line, so it shows some diminishing property and which helps often in case of polygon. The curve generally follows the shape of defining polygon. Any transformation can be applied to the curve by applying it to the vertices of the defining polygon, right? Any transformation can be applied to the curve by applying it to the vertices of defining polygon. The curved line within the convex hull of its defining polygon. The curved line within the convex hull of its defining polygon. Did you get this property, last one? The curved line within the convex hull of its defining polygon. The curve lies within the polygon which is defined, predefined. The curve lies within it.